So now we have exported the models, and now it's time to do our inference cycle. Now the inference cycle we will do through a script. Let's look at this script. So to start off, we import a lot of our packages. Now many of these packages comes with the object detection API itself. So these are native classes which are used for many of the utilities we have. Then let's the first we define some of the paths to the model directory. So first we define the path to the exported models. So our exported models, whichever are your exported models, you can define the path to here. So I had exported two different models, so I have selected my model SST. So that's what I've selected. So that's your base directory. And then you also give the path to the CFG files, which is the configuration files, which is within this. So you have this configuration file. So that's the path which you give, and the checkpoint information and the checkpoint folder. So these paths you give. So we just now we'll get into the process of loading the model and then loading the checkpoint into the model. So again, for this you have specific utilities for this, which comes as part of your object detection API. So this is a utility to load the configuration files in a specific format which is required. So you load the config files using this utility. So the path to CFG is this. So you read the pipeline.config and then store it in a specific format called the config. Next is to load the model. The detection model is loaded through a model builder. So again, this is another utility which comes with the API. So you load the model, which we saved as a detection model, which we give the configuration files also. So which is the which are the specific configurations for those models, and then we specify that this is not for training. So we put, since there is an inference cycle, we put it as training is false. So next is to, once this model is there, so that's a model object which is there, and then now we have to load the checkpoint information. So whatever we have trained, the checkpoint model parameters have to be loaded into the model. That's what is done here in these two steps. So all these checkpoint information are loaded into the model. So that's a step of loading the model and making it ready. Now this loaded model, the detection model, will be used for a inference cycle. So before we get into the main script, so there are some utility functions which are required for this. So this is to do the predictions. We'll come to that. We'll look into each of these functions in a little more detail. And the other one is to convert input image into an array format. So that's one of these things. We'll see these two functions which is in use. Now let's look at the specific process what we'll do. So first we also get the path to the labels. So now we have the label map.pbtx, which we know that is in our annotation file, and we get the path, and then we get something called a category index. Now category index is just like your dictionary, which is a mapping between the class name and the index. That's all. So it's nothing different. And then we give the path to the test files. Now these are not, so if you have any other set of test files, you can give the path here. So whatever is your path to your text files, you give it here. So all the text files are all the test files, not the text files, all the test files, JPG files which you want to test for inference are listed here. Now what we're going to do is we're going to iterate through each of those images. So you have all these paths here, and then to each of this image path you are iterating it. And then first what you're doing is you're converting that, you read the image and then convert into an array. So that is using this function here. So it's just a simple function. It just opens the image and then converts into an NP array. So image NP is an array, a NumPy array of our image, and then we convert it into a tensor also. Now if you the input NumPy array would be three dimensional. So you will have the height, width, and the channels. But for inference, we need a fourth dimension, which is your batch size, because that's how we did our training. It had a fourth dimension, which is the number of. So if we had 16 training images, or the batch size of 4, for example, so your total training object was 4 into the dimensions of the image. So to do the inference, we'll have to convert this 3-dimensional into a 4-dimensional, and the 4th-dimensional will be 1 for instance. Since we are doing an inference for each image, it will be 1. So that's what is done here. And then what we do is we get the detections. So you use a detect function here. So the detect function is this. So first we take the image which we give. So we give the image, which is your input tensor, that 4-dimensional image which has been converted. So we give that image here, and you get two objects, image and shapes. Let me just show you that specifically. So let's look at those objects. So you have two objects like images and shapes. So images is a tensor shape like this, and shapes is another object which is there. Now these two objects are passed into a prediction dictionary. So this is where you do a prediction. So this prediction dictionary is in a specific format like this. So where you have for each of those you have a complete array with all those predicted values. Now this has to be converted into our bounding boxes and the number of detections, and that is done through the post process. So what the post process does is it takes this dictionary, which is these pre-processed inputs, along with so many other things are there, feature maps and so many other things. These are part of how the outputs are, and it takes that and then makes the detections. Now these detections will have. Let's look at closely about what these detections are. So these are the detections. So these detections have got different things like your boxes. These are your different bounding boxes which we have found. So four coordinates which we have there. Another thing which you have to note here is the shape is 100. 1 into 100 into 4. Now what is this 100? So let's go back to a pipeline config file. So in our config file, we have defined that the total number of detections which we want is 100. So that's why this is 100. So what it does is whether there is a object or not, it finds tries to build a detection for 100 different objects. So whatever you define here in the config, it'll have an array of that shape. So if you look at it, this specific the first thing, detection boxes, the only 6 of them have got a values. For the first 6, the rest is all zeros. That means it has actually detected only 6 objects within that specific image. However, since we have already defined a minimum number of detections as 100, so it has got all the other values have been as zeros. Similarly, now you have a detection score also. This is the confidence score for each of them. Then you have what is the detection classes for them. What are those classes for those images, for those detections? So as you know, we have 6 six objects which has been detected and classes for that. So here number of detections, we can see that this is 6. Then the raw detection boxes, what are the raw detection boxes for that? These are all predicted after the these are all predicted from the deep learning model. So just like what we saw in YOLO in the previous post, the model which we have selected is an end-to-end model which does the detection, predicts the class of the detection, and also predicts the bounding box where that specific images are. So all these codes are part of that detection, those detections. So now so for each of these each of those images we get all those detections, so which has many of these things. Now what we need to do is we need to take only those objects, only those places where there are objects. So we know that there are, so we extract the number of detections from that from the library, from the dictionary, not the library, from the dictionary. So we take the number of detections. So this number of detection in our case would be 6, because we have seen that the number of detections are 6 here. So number of detections is 6. Now what we're going to do is we are going to iterate through each of those keys, each of those items. So as you said, as we saw, there are different items here, so many different items as part of the detections, and we are going to pass iterate through each of them and take only the first 6, because we know that only the first 6 contains the objects which we want. So those are extracted here, and then we define the number of detections, and detection class we are defining as an integer, and then we have a special visualization utility also, which comes as part of the object detections. So here in this visualization utility, what we give is we give the image NP with detection. So these are our image which we have loaded. Then the detection boxes, detection classes, and detection scores. These are your confidence scores. The category index. All these things are given to this. So this image NP with detection is just a image copy which we have taken. You just copied that same image, this NP array, and given it here. And then we also give maximum boxes to draw is 200, and then we are giving a threshold here, saying that only if the threshold or the probability threshold is greater than some percentage, you need to visualize this. So you can change this value and then see what we have, and then what we do is we again take the image. From this image NP with detection and show the image. So what it does is, this whole utility, what it does is it takes all those detection objects and then draws bounding boxes into it. So we'll see that in action when we run this inference load model.py. This file we'll run and then see our inference cycle. That's what we'll see in the next video.